Hi and Assalamualaikum. We are from group BA1 section 3. We will present about tidal energy, tidal turbines for our fluid of mechanic group project.
This is our group members. First is Muhammad Afifawas bin Famizam, Darwish bin Ahmad Nazri, and me, Ahmad Shazwan bin Jeffrey.
For introduction, tidal power or tidal energy is harnessed by converting energy from tides into useful forms of power, mainly electricity, using various methods. Although not yet widely used, tidal energy has the potential for future electricity generation. Tides are more predictable than the wind and the sun. More specifically, tidal generator will convert the energy obtained from the earth tides into what we would consider a useful form of power, example electricity. Among sources of renewable energy, tidal energy has traditionally suffered from relatively high costs and limited available of sites with sufficiently high tidal range of flow velocities, thus constricting in total availability. However, many recent technology developments and improvements, both in design and turbine technology, indicate that the total availability of tidal power may be much higher than previously assumed, and that economic and environmental costs may be brought down the competitive level. Tidal energy production is still in its infancy. The amount of power produced so far has been small. There are very few commercial-sized tidal power plants operating in the world. Next is for construction process. There are many ways to capture tidal energy, but the three most popular tidal technologies are tidal barrage, tidal fences, and tidal turbines. Each method has its own strengths and weakness, and we will first better understand the three different methods of capturing the energy before we discuss about construction process. The first one is tidal barrage. Tidal barrage has been proven to be the most efficiently tidal energy technology. It's engineered like a dam that utilizes the potential energy generated by the change in height between high and low tides. This electricity is then transported in real time by a power plant that is stationed on shore. For the second one is tidal fences. Tidal fences are turbines that operate like giant turnstiles. As water passes through the mechanism, it pushes the giant turbines and causes them to spin, producing electricity. The giant fences allow for more surface area when compared to the other two methods. For tidal turbines are similar to wind turbines, but they operate underwater. Tidal turbines generate electricity when the mechanical energy of tidal currents turn the turbines connect to an electrical generator. The generator then produces electricity, but unlike wind turbines, these tidal turbines are being turned by ocean current versus air current. It is said that ocean water is 800 times denser than air and therefore applies a greater force on the turbine. When designing tidal turbines, the engineer must take into consideration all the challenges associated with a dynamic physical environment of a subsea location. The density, pressure, salt and temperature of the water are all the major factors in determining the material used to build the turbines. The blade feature a sprocket mold with unidirectional carbon prepreg and glass prepreg. The shell are all glass prepreg and all components are oven cured. The blades are 9 meter or 29.5 feet long and weigh 2000 kg. The composite blade has a lifespan of 25 years and only require minimal maintenance. The turbine's 1 MW rating equates to providing sufficient power to approximately 500 homes. These previously referenced forms of renewable energy are not as difficult to construct as suggested in the past. Although a good portion of marine construction activity is required, it is fairly easy. Assembly in a factory and then transport on the site. Once on the site, you will then load them onto a vessel and haul them out at sea. Once out at sea, you will place them in predetermined location in the water using a crane. The track and lines will have to be laid down as well, which will require underwater welding. The plant itself will be located on shore and built like any standard power plant. And then it is need to lay new power cable to transport the electricity as needed.
I will continue about the technology tidal energy. Okay, first we have horizontal axis turbine. The design for tidal energy extraction come in a plethora of shapes, size and forms, although principally they are all harnessing either potential energy or kinetic energy from the tide and converting it into electricity. Okay, second we have vertical axis tidal turbine. Developing countries considering the capabilities of production technology and marine environments condition. Okay, lastly is enclosed axis turbine. Okay, this technology may allow for function over a wider range of current velocities, thus producing more electricity per unit of rotor area. It also generates electricity from moving water currents or ocean tides.
There are 4 issues in this project. First one is environmental concerns. Tidal power can affect marine life. The turbines or rotating blades can accidentally kill swimming sea life. Projects such as the one in Stanford include a safety mechanism that turns off the turbine when marine animals approach. These features cause a major loss in energy because of the amount of marine life that passes through the turbines. For the second one is corrosion. Salt water causes corrosion in metal parts of tidal streams generator. Proper maintenance can minimize the number of harmful chemicals that may enter the environment. Use of corrosion-resistant materials such as stainless steel, high nickel alloys, and titanium can greatly reduce corrosion damage. For the third one is fouling. Materials and coatings tested by Leicester Pearson College divers to assist clean current in reducing fouling on the turbine and other underwater infrastructure. Tidal current is an area of high tidal currents and high biological productivity in the ocean where high water temperatures and sedimentation create an ideal environment for life. For the last one is cost. Tidal energy has high initial cost, which may be on the reason why it is not a popular source of renewable energy. Tidal energy is still very early in the research process, and it may be possible to reduce cost in future. The cost effectiveness varies according to site of the tidal generators.
For the conclusion and recommendation, okay, as a conclusion, in order to capture energy from free or extremely low headwater flow, the tidal energy sector must create a new generation of ecologically friendly, cost-effective and efficient equipment. Tidal barrage adverse effect on the environment are probably considerably less severe than those of other electrical sources, although they are not yet fully understood. Okay, whenever evaluating the amount of energy that could be accessible at a possible tidal energy site, it is crucial to take energy extraction into account. Okay, he extends which humanity uses the moon's gravitational force will ultimately depend on how much alternative energy sources will cost in the future and how much environmental effect they will have. Okay, lastly is the bulk of this tidal energy source is now underutilized, but if it were to be adequately harvested using properly designed system, it may significantly contribute to meeting our country future energy demands. That's all from me. Thank you.